Going to explain why a to the m over a to the n is equal to a to the power m minus n, and along the way we're going to need to use the formula a to the m times a to the n equals to a to the m plus. However, the use of these variables a, m, and n are going to clash with what we already have. To avoid confusion, I'm going to rewrite this formula right here just a different way, just using different letters as b to the as b to the y times b to the z is equal to b to the y plus c. Same formula either way, but now we won't run into any sort of confusion notationally. So to show why this formula is true, what I'll do is I'll start with the left side. I'll have a to the m over a to the. Now I can rewrite that as a to the m over 1 times 1 over a to the n. This looks a little funny, but if we had something that looked like this, normally we'd multiply the two fractions by multiplying across, and a to the m as the first numerator, 1 as the second numerator, their product is a to the m, and then the denominator 1 times a to the n is a to the n. So this is allowable, even if it does look a little strange. This first fraction right here, if I simplify that and write the result right here, a to the m over 1 is just a to the m. Let me erase the last bit of work then. And then I'll write in this multiplication dot, which is the one that's right here. And now 1 over a to the n. Earlier we had seen a to the negative n is equal to 1 over a to the n. I'm just going to use that now and replace 1 over a to the n with a to the negative n right here. Now we are in a place. That. So we just used that. Let me just get it out of the way though. And now we're in a place where this formula right here applies. You see the b that shows up here in our expression right here happens to be a, and then the y that appears here in this formula is the m in our problem, and then the z that appears is actually negative n. So if I apply that, I could write down something that looks like this instead. And I'll have a to the power, up here it says y plus z, and so I should have m for my y plus negative n for the z. And then another way to write a to the power m plus negative n is I have a to the power, I can rewrite the m plus negative n as just m minus n. So now you see this is equal to that. Each time, each step along the way, we have quite a bit of quite an argument to get to here. So just as a reminder, what did we do for that equal sign was we had to remind ourselves of some earlier truth, namely the rules for multiplying fractions. This next step here involved two things. It involved saying dividing by 1. You don't have to write that. It also involved this formula right here. And then this step right here is making use of this other old formula that when you have two things you're multiplying with the same base, you add the exponent. And then finally, in this last step, we dealt with adding a negative numbers, just the same thing as subtracting.